in this video we're going to learn how to multiply and divide complex numbers. Now that should ring a bell because we've already done that, except this time we're going to do it in polar form. So here's 4 examples. They look extremely complicated, extremely messy, but we're going to be able to do this really quickly. I will first explain how we'll do that. That'll take us a few minutes, that'll take us a bit longer, but once we do these questions, they will be able to just write them down. They'll take no longer than writing them down. Now in the last video we learned how to change from rectangular form into this polar form here. So just to remind you of that, if we had 2 plus 3i, we can change this to look like a number here. To look like where it has an or. So these are all 2 numbers multiplying, 2 numbers dividing. So for example, I would have an or and an angle. An or and an angle. We'd get that information from this. You do need to have seen that last video, so please go back and check that out. Now I'm going to explain how we multiply 2 numbers. To do that, I'll start with some generic numbers. We'll say or 1, so that's where we have a number in front of here. We call that the or, the modulus, and cosine, and we have an angle, plus I sine, and we have the same angle. That's how we write a complex number in polar form. Now we're going to have 2 of these, so let's multiply that by or 2, a different number than or 1, multiplied by cosine, another angle, plus I sine b. Now I'm going to need a lot of room here, so this should be enough for me to multiply these 2 out. Let's see, we or 1 can multiply or 2, there's nothing complicated there. We can just write or 1 or 2, that'll be the same all the way till the end. And then we just have to multiply these brackets out. Cosine A by cosine B, cosine A by sine B, sine A by cosine B, sine A by sine B. So there's going to get 4 of these numbers. It's going to be fairly long and messy. First, let's try and organize them before we do that. There's going to be real ones. This real number by this real number will give us a real number. Let's start with the real ones then. So we'll have cosine A, cosine B. That'll be a real number. Where else will we get a real number? Real by imaginary is imaginary. Imaginary by real is imaginary. Imaginary by imaginary, that will come out as real. I times I is I squared, which is the same as minus 1. Sine, and then we'll have sine A by sine B. So that would be our real parts. This would be a good way to keep it separated. And then we're going to have an imaginary part. So let's just leave the I out front. We'll have sine A by cosine B. Sine A by cosine B. That's a bad B. Let me try that again. And we'll have, let's see, sine B by cosine A. So sine B by cosine A. Okay, let's close this bracket here. Now, at this point, we get to use some trigonometric identities that we haven't actually proven in this course. When we start doing trigonometry, we can prove this, and we will just show. For now, it's given to us in most formula tables. It's a fairly standard trigonometric identity. It's not too hard to prove, but it will just take too long into this video. And this part here, let's separate it out. Well, let's write or 1 or 2. That hasn't changed. This part here is simply the same as cosine A plus B. That's the trigonometric identity. We can prove this. If you're wondering, ask me in the comments below. I will point you well, hopefully I'll point you to my own video that might be up by now, but that'll be a few months from this video being up. But otherwise, I'll point you to a video somewhere online or some information, or I'll try and explain it myself in the comments. This does in fact equal this. So and similarly again, we'd have a plus and we'd have an I. And this part here, this one is another trigonometric identity, and that is simply equal to sine A plus B. Let's close this bracket. That's how you multiply 2 complex numbers in this form. The ors simply multiply, and the angles, the A's and the B's, simply add together. That's how we multiply 2 complex numbers. And as well, I won't prove the second one. I won't prove how to divide, but I'll write down what it is. I'll put it here, and I think I can fit all my answers over here. To divide, let's put it here. Or 1 cosine A plus I sine A. bracket there, R1 acts on everybody, divided by R2 cosine B plus I sine B. That is going to be equal. The R1 divides the R2 just like normal. R2. And you could, by the way, here'd be a bit of homework for you. You can prove this just like I did here. You have to be careful. You have to divide these like we learned how to divide by multiplying by the complex conjugate. It would be a little bigger than this, a little messier than this, and you'd have to keep an eye out for some of these identities. There's 4 famous ones. This is 1, this is 2, and 3 and 4 will appear when you do this. Okay, so I'll leave that as a bit of homework. What you will actually get is cosine A minus B. Let's open a bracket there. Plus I sine A minus B. Okay, so that's how we would divide two complex numbers in this form. This complex number divided by this complex number, we can quickly get the answer. So hopefully you can see now that how quickly I'm going to be able to do all these. I think I can squeeze them all into this space. I might be wrong there. My handwriting's not the best. So the very first one, to multiply these two, OR is 2. There's no OR here. That means OR must be 1. So the answer is 2 times 1. The new OR is 2 in that case. Cosine 30, cosine 50. The new answer is cosine 80. 30 plus 50. That's what happens when we multiply. Plus I sine 80. That's our answer. That's how quick it is to multiply in these polar forms. That's how powerful this is. Number 2. Do you notice something different here? Instead of angles, instead of degrees, I have radians. Again, we haven't done trigonometry. We haven't talked about radians too much. These are much more preferred in mathematics. I've mentioned them once or twice. In mathematics, I'm much rather using these. These are just something we made up thousands of years ago because we thought 180 was a good number. We thought 360 was a good number. Really, this is a very good number. Pi is a good number, not 360. So I'd much rather be using this. Get used to using two different ones. You do need to be able to change between them. They aren't too complicated, but we'll talk about it more in trigonometry. Okay, we have the OR1 is square root 2. OR2 is square root of 8. Multiplying them together, we get square root of 16. I can do that luckily in my head, is 4. And then we have cosine of pi over 3 plus pi over 6. A little harder to do in my head. But this is 2 pi over 6 plus pi over 6 gets me 3 pi over 6, which is the same as pi over 2. 1 pi over 2. Okay, you might need to do that a little slower. Unfortunately, I didn't give myself much room to do that. So you're going to have to trust me or test that yourself with a piece of paper. Ask me in the comments below if you're unsure. I and sine pi over 2. Luckily, you only have to do the sum once. Same each time. Okay, let's do the dividing. They're just as easy. Number 3. We get the OR first. OR1 divided by OR2 is 4. 8 divided by 2 is 4. And we have the angle. Let me write all this out first, actually. Plus I sine. It's really just the angle we need. And the angle is found by this angle minus this angle. 3 pi over 4 minus 1 pi over 4 is 2 pi over 4. 3 pi over 4s minus 1 pi over 4s is 2 pi over 4s. 2 over 4 is the same as a half. That's pi over 2. Again, same answer as up here actually. Pi over 2. And number 4. So hopefully you're seeing how ridiculously easy multiplying and divide is in this. We're then going to see how easy it will be to get the power. Because the power is just lots of multiplying. Multiplying is very easy. So is divide. So this one, 2 divided by square root of 2. A little harder, but is actually square root of 2 is the answer. 2 is made up of square root of 2 multiplied by square root of 2. So when you divide it in, we get square root of 2. Check that yourself. Don't trust me. Test it yourself. We still need to find this what angle goes here. They're using degrees. I don't like it, but fine. I'll use degrees here. I made the question, so I shouldn't complain. 74 minus 21 is 53. Look how easy it is. This is extremely easy to do. That's how we multiply. Much easier than adding, in fact. Adding is difficult in polar form. Multiplying and dividing, very easy. Okay, if you have any questions about how I did that or why I did that, just to recap what I left off, I proved most of where the multiply comes from. I left out a trigonomic identity. Research that yourself. I'll get to it in a future video in trigonometry. I also left out how to do how to prove the dividing. Very similar to multiply. I'll leave that as a bit of homework for you. And that's how easy then it becomes with these formulas. Okay, thank you for watching and have a good day.